Hello, this is Steve Sokol from Open Flight Solutions, and this is a quick demonstration of the new FlightBox EFIS system that we're working on. This is actually being flown on a simulator, so it's a little bit easier for me to talk to you and I can actually pause things. First, a quick introduction to what you're seeing here. On the right-hand side of the screen, you're seeing the MFD portion, which right now is showing our aircraft parked on the ramp at Reed Hillview Airport in San Jose, California. The left-hand side of the screen, you're seeing the PFD, or Primary Flight Display. Across the bottom of the screen, you're seeing the engine monitoring display, and slightly below that is the menu or operation bar. Across the very top, you see a status indicator showing that we've got marginal ADS-B reception, good GPS, ARs, air data computer, and engine monitoring system, and that we're both full charged and connected to AC power. In the middle of that, you see our flight timer information. Local time is a few minutes after noon. Zulu time is 2017, and flight time right now is 0:0 because we haven't moved yet. We have our transponder set to altitude mode, and value set for it in the comm. Right now is set to the emergency channel. Let's go fix that first of all. So we're going to tap comm radio, and since we're at Reed Hillview, first thing we'll probably need to do is get the ATIS. So bring that up. You'll note the COM1 value in the upper right-hand corner changes. In the real aircraft that this is hooked up in, that sends a signal to the SL40 COM that causes it to change the frequency. This also works with SL30s and with VAL avionics and probably with a few others. In the simulator, it doesn't really do much of anything other than update the display on the screen. But we pick up the ATIS. You find out that the sea level pressure here is 29.92, so we're going to exit out of this. I'm going to come over and adjust that down. Now you see me using a manual scroll on the screen there. There's actually also physical controls we can use. Our TTI controller. I don't actually have one of those hooked up on this because I'm actually using the new iPad. What is this? This is the 11-inch iPad Pro. So okay, we've just adjusted our baro pressure. Now, if you had multiple displays, that would actually be replicated onto all of the other displays. We actually synchronize settings across all of these guys. So if you had a dual or triple screen setup, all of a sudden that would be updated. Now, I say dual or triple screen, you may want to note that right now we're looking at this in its default configuration with PFD, MFD, and engine monitor. All those things can actually be adjusted and moved around. So if we want to change things, just to give you a quick demo, I'll hit the display button down here and I'll turn off split screen. And bang, all of a sudden we're looking at purely the primary flight display. Now, for this case, because I don't have a secondary display to put the MFD on, I'm going to switch back. We're going to go back to split screen. There we go. So now that we've got everything kind of set up, let's take a look at a couple of other things. In the upper left-hand side of the PFD, you see the indicated airspeed bug value set at 130, which is about normal for this aircraft. We're flying a fake Grumman Tiger. On the right-hand side, we've got the altitude set to 900 feet, which is probably a little bit low. So let's set our target altitude up to 4,500 feet or so. Now I'm going to do that knowing full well that there's some of the Bravo that we fly through here where all of a sudden that's going to be a problem. Now, if you'll take a look at the upper right-hand corner of the MFD, you'll see right now there's a little box there that says Inside D, 0 to 2,000. That indicates that we're inside of a Class Delta airspace that extends from the surface up to 2,000 feet. As we move through different airspaces or as we approach different airspaces, you'll actually see that value change. So that's an important sort of useful thing, especially if you're flying in some place like San Francisco Bay Area, which has really complicated airspace. All right, so let's go to the process of flying. We're at Reed Hillview and we want to fly, let's do something fairly simple. We're going to fly to, Livermore, I think. So if we zoom out and zoom by pinching, you'll also be able to zoom by stretching stuff around manually. We'll see, okay, here we are, we're sort of headed a bit to the, faced off to the east right now. And there is Livermore, KLVK. We can tap on that, and we can just add direct to. That's one easy way of setting navigation on this. Now you'll notice that the HSI over here on the left-hand side of the screen automatically updated to reflect that. We can also do this a couple of other ways. If you hit the navigation button and then go to flight plan, you'll see that we have starting out at a user-defined waypoint and going to Livermore Municipal. Rather than using the user-defined waypoint, let's actually formalize this. We're going to add RHV here, which is code for Reed Hillview. Save that. We'll delete that waypoint out of there. It looks exactly the same, but now the information that gets stored related to the flight is a little bit more precise. It knows what airport it's coming from and what airport it's going to. So, zoom back in. Also, I'll mention something here. We're going to set the display mode to, it's already set to auto zoom. So as we take off, or even as we taxi, you'll see the zoom change around. So let's go ahead and get started with the flight. Gonna release the brakes on our virtual Tiger here. And you'll have to pardon me, I'm not the world's best driver of this simulator. So I'm gonna start up, and we're gonna taxi out. Alright, so here we are. We're almost over to runway 13 left. It's going to give us a southbound takeoff, and then we'll swing around and head back north. Alright, here we are now. We're more or less lined up. We will go ahead and start our ground roll. And off we go. That was a pretty sloppy takeoff, I'll admit. And go ahead and make our left turnout. Tower gives us permission to go ahead and turn on course. All right. Now again, take a look at that airspace indication. It's in the upper right-hand corner, and you'll see that we're inside the Class D airspace for Reed Hillview, but we're also, as we climb here, approaching a Bravo point. We will enter below the Bravo. We're actually going to be quite a bit below it, because that's the 8,000 to 10,000 foot shelf, so nothing we're worried about. And that's why that shows up in green. But also seeing that up ahead there's another Bravo shelf, which is 7,000 to 10,000 feet. It's a little further ahead, and again it's in green because it's no factor. We're well below those. But we're going to climb on up, with our expectation being that we'll cruise out to Livermore at 4,500. If you've ever flown a Tiger, it takes a little while. It's not the best climber in the world, but it'll get us there. All right, here we are. We're cruising through 2,200 feet. We're almost to our course line. Our airspeed is about 110, which is normal for a Tiger on a climb. Engine is looking good. And as we approach our course here, all right, about this point, as we're exiting the Delta airspace for Reed Hillview, which is now below us. It only goes up to 2,000 feet. Go ahead and turn on course here, continue to climb, and we're instructed to go ahead and contact NorCal approach for VFR flight following. So, okay, comm radio, NorCal approach. NorCal approach, Tiger 1234. We're a few miles off of Reed Hillview, en route to Livermore. Request flight following. So there we go. All right, at this point, it gets pretty boring. I have a little bit to note. Because actually, in this case, because we're going to Livermore, we never intersect the Class Bravo. Class Bravo remains far enough above us and away from us that we're not really going to have any problems with that. You'll notice the change in zoom level as we get further away from our origin point and transition into cruise phase, or en route phase. The system automatically detects that and adjusts to a zoom level that's appropriate for that, so you can see further ahead and further around. For this short flight, that may actually be a little bit aggressive, but you can always go in and turn off auto zoom and then adjust the zoom as we want. Auto zoom's kind of nice because as you arrive someplace, it takes care of zooming in and you're not having to sit there and twist on the knobs or tap on the screen to try to adjust your... Alright, if you look over now at the bug indicator for the altitude, you see that we're approaching 4,500 feet, which is our target altitude for this flight. Gets us over these little mountains you see without any problem. Go ahead and level off. Move the nose a bit. There we go. Throttle back a little bit too. Unfortunately, I don't have really good trim controls on this simulator at the moment, so it's easy to overshoot your altitude a little bit, or undershoot it. Oh, notice we just saw a jump there because we switched to a new closest METAR, which gave us a new baro setting. Is actually being pulled from live METARs. On the ground, that comes over the internet if you have an internet connection, like a cellular connection. In the air, that comes from the ADS-B uplink. And because, again, this is on a simulator, there's a little bit of disparity between what it thinks sea level pressure is and what the actual updates coming from Livermore, Reed Hillview, and some of these other airports around here are. So that's why you see a bit of a disparity. Alright, one little bit of information about this. We can see from those blue lines, those are our two parallel runways that are appearing there. So we've got two choices to land, and of course Tower will tell us where to go for real. But if we want some information, we can tap it, and we have information available. So elevation, we're going to be at 400 feet when we touch down. There's a control tower at this airport. Got some frequencies, which we can also get to from our comm radio interface. Check the weather here. Visibility 9 miles. Altimeter 30.27. Alright, winds are, let's see, 12 knots out of the east. Not a problem. And then runway, I'm pretty sure they'll have us landing to the east, so runway 7 right or runway 7 left. Let's call them up and see. So let's get comm radio. And now it's got destination selected here. So we'll go ahead and contact, get Livermore's ATIS first, and it'll tell us more or less the same information we just got from the ADS-B uplink. And then you can switch over to Livermore Tower, and they'll tell us, okay, we're what are we? We're 7 miles to the south with November for full stop landing. Oh, take a look over there in the upper right-hand corner again, and you'll see that it's showing that the Delta airspace for Livermore is ahead. It's 2.6 miles ahead, and at this point it's below us. In fact, because it's below us, we probably ought to start slowing down a little bit. So we're coming to the edge of the mountains, and now we need to go from where we are down to 400 feet. Alright, here we are. We're getting down to below 2,000 feet. We're getting closer to our airport. It's over there on the far side of this little valley. One thing that's on the agenda for a future update of this is terrain information. It's definitely something that's nice to have out here. Okay. Let's go ahead and kick our auto zoom back on. And as we approach, there we go. It'll automatically zoom in to points where we can see where the runways are, how we're going to intersect them, etc. Not the prettiest landing, but not too bad. And there we go. We have repositioned an aircraft from Reed Hillview to Livermore in a fairly short period of time using the new FlightBox EFIS. Thanks for watching.